we shall solve some more problems on matrices. If capital A is equal to 3, negative 2, 4, negative 2 and I means identity matrix 1, 0, 0, 1, then find the value of k so that A square is equal to ka minus 2i. Here, how to solve it? It's a very simple question. We will consider the left hand side LHS, that is equal to A square. A square means we have to multiply A by A. That is, we will write 3 negative 2 4 negative 2 multiplied by itself, that is 3 negative 2 4 negative 2. So we can obtain, that is 1 negative 2 4 negative 4. So this is our left hand side. Now what is right hand side? So right hand side is equal to Ka. What do you mean by Ka? We have to multiply every element of capital A by K. So we can get it, that is 3K, then minus 2K, 4K, then minus 2K, then minus 2i. 2i means we have to multiply every element of capital I by 2. That is, we can have 2, 0, 0, 2. On simplification, that is subtraction, we can have 3k minus 2 minus 2k 4k minus 2k minus 2. So this is our right hand side. Now as per the question, LHS is equal to RHS. LHS is equal to RHS. So one can obtain 1 negative 2 4 negative 4 is equal to 3k minus 2 minus 2k 4k negative 2k minus 2. So we know that equality of matrices. Equality of matrices means we know corresponding elements should be equal. Therefore, by equating the corresponding elements, 1 is equal to 3k minus 2. We can simplify to get k is equal to 1 here. So you can see that when k is equal to 1, what will happen to this minus 2k? That will be negative 2. When k is equal to 1, what will happen to this 4k? That will be this 4 only. And when k is equal to 1, what will happen to negative 2k minus 2? That will be, you can see, negative 4 only. So our answer is correct. So k is equal to 1. Now another question. If capital A is equal to 2 by 2 matrix 1, 2, 3, 4, then verify that A square minus 5A minus 2I is equal to O means 0 matrix. This question is once again very simple. First of all, we have to find A square. A square means, you know, A into A. That is, we have to multiply 1, 2, 3, 4 by 1, 2, 3, 4. By row column matrix multiplication, we can obtain that is equal to 7, 10, 15, then 22. Now, let us consider A square minus 5A minus 2I, that is equal to A square means we already obtained, that is 7, 10, 15, 22, then minus 5A. What do you mean by 5A? We have to multiply every element of capital A by 5. That is, we can have 5 into 1, 5 into 2, 5 into 3, 5 into 4. Then we can have 2i. What do you mean by 2i? 2i means 2, 0, 0, 2. So, simplifying, what we can have? That is 7 minus 5 minus 2. 7 minus 5, then minus 2. So 0. Then 10 minus 10 minus 0 means 0. Then 15 minus 15 minus 0. So 0. Then again we can have 22 minus 20, then 2. So that is again we can have 0. So that is nothing but 0 matrix, hence the verification. Hence the verification. That's all. See another practical situation of a matrix multiplication. A trust fund has rupees 30,000 that must be invested in two different types of bonds. The first bond pays 5% interest per year and the second bond pays 7% interest per year. Using matrix multiplication, determine how to divide rupees 30,000 among the two bonds if the trust fund must obtain an annual total interest of rupees 1,800. Now let X be the amount to be invested in the first bond. X be the amount to be invested in first type of bond. Then remaining amount. What is remaining amount? Because we are having totally 30,000. Then X we are investing in the first type. So remaining should be 30,000 minus X to be invested in the second type of bond. In the second type of bond. Thus, we can have a matrix that is amount X, the remaining amount 30,000 minus X as our first matrix, say capital A. Then the second matrix, that is interest paid by first type bond and second type bond. First type 5% and second type 7%. So here we can have another matrix that is like this. Thus we have two matrices. The first matrix is X 30,000 minus X and the second one is 5 by 100, 7 by 100. Now the interest obtained from the first type of bond, that is 5% of this amount, and from in the second type of bond we can have 7% of this amount. Therefore the total amount, that is nothing but in terms of matrix multiplication, that is X row column method, we have to multiply by row column. So that is X into, we have to multiply by 5 by 100 plus 30,000 minus X, then 7% of it. And that is nothing but the total interest. That's the third matrix actually we have. This is matrix 1 by 1 matrix, of course. And we can simplify a little bit. That is equal to 5x plus 30,000 minus x into 7. A total divided by 100, that is equal to 1800. Now you see that two matrices are equal, means corresponding elements equal. Therefore 5x plus 30,000 minus x into 7 divided by 100 is equal to 1800. On simplification we can have that is 5x plus 2,10,000 minus 7x is equal to 1,80,000, and then we can simplify further to get x is equal to 15,000. The amount to be invested in the first type of bond, and the remaining amount 15,000 to be invested in the second type of bond. That's all. Here look at capital A is equal to, that is matrix 392, 492. The main diagonal elements 3 and 82. So from that you have to make one equation, that is lambda minus 3 into lambda minus 2. Then minus the off diagonal elements, that is 4 and 82. That is 4 into negative 2, that is equal to 0. So how this equation? You see the main diagonal elements are 3, negative 2. So from that we are writing lambda minus 3 and negative 2. You can see this 3 and negative 2 are the main diagonal elements and these are the off diagonal elements. Now let us simplify, that is lambda minus 3 into lambda plus 2 minus, then here it is a negative, therefore 4 into negative 2 again minus, so that is equal to plus 8 is equal to 0. Further to simplify, that is lambda square then minus lambda plus 2 is equal to 0, that you can see. You can write from this equation a square minus a plus 2 is equal to 0. Now you can write it again, that is a square is equal to a minus 2i. Then compare this equation with the given equation, that is a square is equal to ka minus 2i. Therefore here it should be 1. So k should be 1. So comparing these two equations, we can have that is k is equal to 1, that's all. K is equal to 1.